Voltage versus current graphs. As we know, the relation is between the voltage and current is linear. That means a straight line. What information we can get from here is the slope, that is y upon x, delta v by delta I is r, that is the resistance. In a similar fashion, if the current versus voltage graphs are given, then from slope we will get inverse of resistance, that is conductance. Now we will study the effect of temperature changes on the resistivity and conductivity. As we have already derived the equation for conductivity, which comes out to be n square by m into relaxation time, and we know that the n square and m is constant, doesn't change with the temperature. Only factor or parameter which will change with the changes in temperature is relaxation time. As the temperature will be increased, we know the collisions will be more and more, that is the frequency of the collision will increase. So the relaxation time, which is time between collision, will decrease. So since the conductivity is directly proportional to relaxation time, it will decrease with increase in temperature. For effect of temperature on resistivity, we know the resistivity is inverse of conductivity. So the resistivity will definitely increase with rise in temperature, and the reason is same. The relaxation time will be smaller, so resistivity will be higher as the temperature is increased. Students, now we will study the effect of temperature on the resistance of metals. Here, mostly, we are talking about the current in conductors, that is metals. Metals have a large number of free electrons in it, and as the temperature is increased, definitely the thermal velocity of these electrons will increase. As we know that this thermal velocity is in random directions, so it doesn't contribute to net flow of charge, and the current due to thermal velocity is 0. But as the temperature is increased, this thermal velocity will increase and cause more number of collisions, and the lattice will also experience the vibration among the ions. So, definitely, the flow of charge will face more resistance. Here is a formula from which we can calculate the resistance if we have given two temperatures and resistance at one temperature is known. Here resistance R1 is at temperature T1, so we can calculate the resistance R2 at temperature T2. Alpha is coefficient of temperature which is positive for metals, and the resistance R2 will definitely be greater than R1 since T2 is greater than T1. So students, now we know that the resistance increases with rise in temperature. So obviously, if we will be asked how the conductance vary with temperature, we may easily say that as the conductance is inverse of resistance, so conductance will decrease with the rise of temperature. Here it is interesting to know that we have used the Newton's law of motion for calculation of drift velocity, which we have calculated earlier, which gives a relation between drift velocity, conductivity, relaxation time. For calculation of this velocity, why we calculated drift velocity using the Newton's law of motion? The answer is electron is considered as a particle here because the de Broglie wavelength is much lesser than the system length. System length is here the distance between collision, that is also called mean free path. When this condition is satisfied, we can apply the Newton's law of motion. If this condition is not satisfied, we cannot apply the Newton's law of motion. Here, de Broglie's wavelength comes out few angstroms, whereas the system length, that is a mean free path, comes out to be hundreds of angstroms. So the condition is satisfied.